Okay. So in the last lecture, the Nernst equation and equilibrium constant, right? And we did also a numerical on it. Today we are going to write a topic which is kind of related to the Nernst equation, but the Nernst equation, not Nernst equation, but rather E naught cell. And we will be able to derive the Nernst equation from this topic. The derivation is not very important. I mean, it has never been asked in the board examinations. But we will see the derivation to get an idea about it. Achha. So write the topic, Gibbs free energy and EMF of cell. So write the topic, Gibbs free energy and EMF of cell. Now, how many of you know this particular formula? Black and white. W, it is equal to Q into V. W, it is equal to Q into V. Work done upon a charge.
Sir, do we have to raise our hand?
No, I'm not asking to raise the hand. No. Just let me know, yes, by yes or no. How many of you know about this particular formula? W is equal to Q to V.
Yes, sir.
What about others?
Yes, sir.
You know this, right? So instead of voltage, I can also write Q into E cell, because the EMF of the cell is also going to give, that is a voltage that is in volts. Okay. Now, before going to forward, this particular Q, it should be in coulombs, and the charge on one electron, is equal to 1.6 into 10 to the power minus 19 coulombs. I hope all of you are aware about this particular value. But whenever we write any reaction, for example, if I write Zn gives Zn2 plus 2 electron, then in that 2 electron is not actually only 2 electrons, but rather we talk in terms of moles. 1 mole of zinc will get oxidized to give 1 mole of Zn2 positive and 2 electrons. So since in chemistry moles, we will calculate the charge on 1 mole of electron, which will be equal to 1.6 into 10 to the power minus 19 multiplied by 6.022 into 10 to the power 23. And when you calculate this complete value, this comes approximately equal to 96500 coulombs. And this whole value of 96500 coulomb, it is equal to 1 Faraday. So what is 1 Faraday? 1 Faraday is nothing. 1 Faraday is the charge on 1 mole of electron. Charge of 1 mole of electron. We can also write it as 1 F. Okay. I hope you must have heard about this particular Faraday thing. Yes or no, please tell me.
Yes, sir.
Yes, sir.
Okay. Now, if I say, let's suppose in our reaction, we cannot specify whether we are going to have 1 mole, 2 moles, 3 moles, 6 moles also we have seen, right? In the case of nickel 2 positive and aluminium 3 positive, we will be having 6 electrons. So if I take n moles of electron, for n moles of electron, the charge will be equal to n 1F for 1 mole of electron, NF for n moles of electron. Please tell me. Makes sense till here? Yes or no?
Yes, sir.
Okay. So we can further write our W, it was equal to Q into V. So Q, it is equal to NF. Voltage will be equal to E cell. Now we have got a formula W, it is equal to NF E cell. Okay. I hope यहाँ तक आप समझ में आया. Can you please copy this down? Then I will explain further. And we will try to involve Gibbs free energy here. Raise your hand once you're done writing. Raise your hand once you're done. Also, this time also many students are late. Please be on time. I can see two Mariam in the class. Is one of you Mariam Batul or Mariam you have joined with two devices?
No, sir, I only joined with one device.
You have joined with one device. There is one more Mariam.
I think it's someone else.
Ah. You don't have any Mariam in the class. You can take a please copy this down. Please raise your hand. Mariam is here for trial class. Can you please turn your mic on, Mariam? जो trial class के लिए आए हैं. Mariam, who is here for the trial class, can you please turn your mic on? Mariam, can you please turn your mic on? Mariam, who is here for the trial class. No, you can't turn your mic on. Waiting for Khadija. Okay, just waiting for Khadija. I think even Khadija must have written most of it. I think she's also. Okay, now you are not going to write anything. Okay, please don't write anything. Just give me a few answers. Okay. Let's suppose you started your day, and initially, like while you have started your day, you have in yourself 10 joules of energy. And at the end of the day, finally, you are left with 4 joules of energy. You started with 10 joules of energy and you ended up with 4 joules of energy. So how much work did you do? Tell me, guys.
6 joules.
How much
6
work?
joules.
6 joules.
6 joules. Correct. 6. That is the work done by you. But what is the change in energy in you? If I talk about that, I will write delta G. It is equal to final minus initial. So final it was 4 minus 10. It will be equal to minus 6 joules. Does this make sense? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Right. So if I talk about you, then the person has, there is a decrease in the energy of person, and that decrease is shown by minus sign. So we can also say that if I want to calculate delta G, what can I do? I can just say it is the negative of work done. Makes sense till here? Yes or no? Please tell me.
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
Enough. We can write that delta G is equal to negative of the work done. Similarly, here also I have work is equal to NFE cell. So delta G will be equal to negative of work done. And what is work done? We have written NFE cell. That's what we are going to write. NFE cell. Makes sense till here? Yes or no? Please tell me.
Yes, sir.
Yes,
And
sir.
if I want to calculate the standard Gibbs free energy, delta G naught, it will be equal to minus NF E naught cell. Minus NF E naught cell. Okay, so these are the two very similar looking, but I hope you can understand. E naught is in the standard condition, EMF is in generic condition, and E cell it will be in general condition. Okay, so please keep writing. And those remarks are self will work only if E cell is positive. Why? Because only when the E cell is positive, F will be always for it positive, N is the number of modes of electron, that is always positive. So when all of these are positive, then the delta G will be negative. When delta G is occur in the galvanic cell. Okay, so we can write galvanic cell will positive because when is positive, G negative, and reaction will be
सर आपकी आवाज अटक रही है.
my internet is very good. So maybe a bit of problem.
Sir, you're glitching.
Can you tell me?
Sir, your voice is cracking.
You're glitching.
Okay, how is it now? Just give me a second. Okay, how is it now? Is it any better?
Yes, sir, it's good.
Yes, sir.
See you. Next is that. I hope you have written till here. Next point, please write with me. The maximum work done by a cell will be equal to, please see here what I'm writing, will be equal to delta G naught in the standard condition, that is the best condition that we can provide, but we will take a mod of that. Mod means we are just converting the negative to positive, which will be equal to the mod of minus NF E naught cell. Okay. So basically what you need to do is you need to calculate the minus NF E naught cell. That value will be in negative. Just convert it to positive. Take a negative sign. Just write the maximum work done is equal to the maximum work done will be in positive. Delta G will be negative. So obviously we have seen that previously also. If delta G is a negative, the work done will be in positive. Okay. Please write here. I am giving you a question. By the way, I'm again asking Mariam, who is here for the trial class, can you please unmute yourself? Chili, please write this question. You don't need to calculate the equilibrium constant. I already informed the team that I don't have access to the mic. Okay, fine, but not a problem. I was not informed by the team. I'm sorry. Please write this question. You don't need to calculate the equilibrium constant. That's was the part of previous lecture. जो हम लोगों ने किया हुआ है, right? You need to calculate the maximum work done by the operation of the cell. It's very easy. Okay, these questions are going to be very easy. It will be very easy in comparison to the Nernst equation problems. Please write this down. Solve it. You just need to calculate the E naught cell multiplied with N and F. Okay. Value of F is you will put that as 96500. Once you're done, send the answers on my website. See, you two I know what is the problem. You need to and what is the value? You have to plug in the value 96500. E naught cell. This E naught cell you need to calculate. E naught nickel positive to nickel and Ag positive to Ag. Okay, so this E naught will need time. And how will you calculate N? I hope you know the trick. Write the chemical reaction, then multiplied by moles. Okay, I hope you know the drill.
तो हम SI यूनिट क्या लिखना जिसकी होने की वजह से
Once you're done, send the answers on WhatsApp. Okay, guys, please send your answers and a few answers. Yeah, that is correct. You just need to do one more that I will. Looking at Z, sir. Oh, a bit of any calculation. Seva, you need to show some calculations. There is no calculation, so I don't know how it happened. I don't know about that.
Oh, okay, sir. I did it in rough. I'll send you the calculation.
Also, how did you get the E naught cell that I don't know? So you need to see that also. You need to show, by the way, how did we calculate E naught cell? I think there you have done some mistake. Sir. I hope there is one. No, Mariam, your and Anna, looking at your answer right now. Statement. Let me show you guys how to do this. So first of all, we will calculate the E0 cell. E0 cell will be equal to E0 cathode minus E0 anode. Okay. So how do you know which is cathode, which is anode? So for this, you need to remember the application of the electrode potential. Which is higher, of course. So E0 cathode will be equal to 0.80 minus what is the E0 anode? The E0 of anode is minus 0.25. This will be equal to 0.80 plus 0.25, which will be equal to 1.05 volts. We need to calculate minus n number of electrons. You can write the balanced chemical reaction from here. How can you write the balanced chemical reaction? See, in cathode, what we're having? Let me explain this. In the cathode, you're having Ag. Okay. In the anode, you're having Ni. So the cell will be something like this: Ni2, Ni2 positive. Then there will be a bridge. Then you will have Ag, Ag positive. Okay. So this will be the whole situation for the cell. Cell reaction. Nickel. ये थोड़ा सा हम नोट कर रखिए Ag plus 2Ag ना reduction. Okay, so you'll be having nickel plus Ag positive, giving us nickel 2 positive plus Ag. Right. So these are the reactant. In blue, I am showing the reactant. In red, I am having the products. Okay. Nickel 2 plus Ag positive to Ag. Now let us look at the charge. The charge is not balanced. What charge are we having in the product side? 2. What charge we are having in the reactant side? Only 1 positive charge. So I'll make that 2 by multiplying 2 Ag positive. Now we are having 2 positive charge, but I need to balance the number of atoms also. This will be 2 Ag. Okay. The number of electrons will be 2 into 1 or 1 into 2. That is going to be always 2. Multiplied by 96500 multiplied by 1.05. Okay, what will be this value? This value will come out as 202650. 202650. Whenever you get delta G, you will write the unit as joules per mole. You will write the value as joules per mole. Okay. Next, you need to calculate the work done. So this is minus the work or the maximum work, max work will be equal to 202650 joules, which can be written as 202.650 kilojoules. Okay. Please copy this down, those who have not done. How is my voice now? Is it any better? Guys? It's better.
सर हम किलो जूल में क्यों लिख रहे हैं आंसर 202.65?
I mean, there is no reason why we are writing in kilojoules. We can leave that in joules also. But most of the time I've seen in marking schemes that convert it into kilojoule. But you can write it in joules and there will be no better in marks. Also, I mean, I think the reason why we are writing kilojoules is basically If I tell you 202650 meters, that will not make much sense to your mind. But if I say 202.650 kilometers, then that will make more sense because 200, approximately 200 kilometers, right? Here.
Yes, sir.
Okay, so I think that is the reason. Raise your hand once you're done, guys. So yes, Mariam, you understood your mistake? Yes or no? Please tell me. Mariam and also I
Yes.
think Zeba also did the same thing.
Yes, sir.
Yes, sir.
Zeba, you also understood. Soha, your answer is also correct. Anna, I did not look at here. Yeah, your answer is also correct. Yeah, I hope now you are aware of the units also. Please mention the units. Okay. Whenever you are writing for delta G, it will be joules per mole. Work done will be always in joules. Okay, work done you will keep that in joules or kilojoule. Similarly, for delta G also you can write it in kilojoules. Okay, minus 202.650 kilojoule per mole. Okay, not an issue. So write one more very simple question. Okay, there was this question asked in 2014. I hope you have written this down. And I think most of you raised your hand. No, only 5 people have raised hand. People are you writing? Khadija, Mariam,
नहीं सर, वो हैंड रेज करके थे.
Khadija. Hand raise करके थे. अच्छा, Siddiqa. Anyone still writing? Please let me know. Anyone still writing? Please let me know.
No, sir.
Anyone still write? Yes, sir. Khadija is right. लिखिए, Khadija आराम से लिखिए. Khadija, now you will let me know once you're done.
Okay, sir.
If you guys are having any doubt, किसी को कुछ doubt है तो please पूछ लीजिए.
Done, sir.
Done. Same concept but different question. ठीक है? Please ध्यान से देखिएगा. Estimate the minimum potential difference. That means they're asking you to calculate the E cell needed to reduce Al2O3 at 500 degrees Celsius. The Gibbs energy change for decomposition reaction is 2Al2O3 gives 4 by 3 Al plus O2. It is equal to how much? 960 kilojoule. ठीक है? Now ध्यान दीजिएगा. Now what we have delta G. It is equal to the Gibbs energy change. It is in positive, है ना? Delta G it is equal to 960. 960. By the way, I need to put 3 more zeros. Joules, because we will get in joules and we will convert that in kilojoule. Okay, so this much we are having, that is the delta G, that gives energy change for the decomposition. Here we are giving energy in this case. And what is the formula? Delta G, it is equal to NF E cell. We need to calculate the E cell, which will be equal to delta G divided by N into F. We have been given the value of F. How to calculate the number of electrons? Look at the change in oxidation state. Change in oxidation state से आपको number of electron पता चल जाएगा. Look at the change in electron state, change in oxidation state. ठीक है? You have been given the, चलिए ठीक है, हम थोड़ा सा यहाँ पे आप लोग की हेल्प कर देते हैं. You have been given the Gibbs energy change for this reaction. So you will also look at the number of electrons consumed in this reaction. So if I talk about Al2O3, so Al2O3 aluminium will be in +3 state. है ना, and this aluminum it is getting converted to 0. Make sense till here? Yes or no? Please tell me.
नहीं सर.
Yes, sir.
नहीं, ठीक है. Let me show it completely. So we are having Al2O3. ठीक है, यहाँ पे 2 aluminium, so you will take 2x minus rather plus कर दीजिए अभी. ठीक है, plus how many oxygen? 3 oxygen. What is the charge on oxygen? -2, which is equal to the charge, overall charge on Al2O3 is equal to 0. So 2x will be equal to 3 into 2 is 6. That it will go plus 6. So x will be equal to plus 3. So the oxidation state of aluminium it is plus 3. And it is getting converted to aluminium. It is aluminium neutral, which is having 0 charge. Makes sense now? Yes or no? Please tell me.
Yes sir.
ठीक है, प्लस ध्यान दीजिएगा, लेकिन यहाँ पे ध्यान दीजिएगा. ठीक है, ऑल ऑफ दीज थिंग्स आर बैलेंस ना. देख लीजिए एक बार, सब चीज बैलेंस है. चलिए, ठीक है, देख लीजिए सब चीज बैलेंस होगा. अब यहाँ पे ध्यान दीजिएगा एक और चीज. One aluminium is undergoing a change of +3. That means there is 3 electron required. Here we are having 2 aluminium. So total electrons will be equal to 6. ठीक है, total electrons per aluminium oxide is equal to 6. How many aluminium oxide we are having? 2 by 3 moles. So we need 6 electrons per mole of aluminium oxide. So for 2 by 3 Al2O3, we will be needing 2 by 3 into 6. Al2O3 के लिए how much we required? 6 electrons. 2 by 3 Al2O3 we required 2 by 3 into 6. So this will be equal to 4 electrons. ये चीज,
Sir,
this is
can you
important. इसको ध्यान से देख लीजिए एक बार.
explain again?
One more. Sorry. What, Mariam?
Can you explain again?
हाँ, Al2O3 से aluminium. ठीक है, we want to go from Al2O3 to aluminium. So from +3 to 0. That is the change in 1 aluminium. For 2 aluminium, what will be the total number of electrons required? 6. So we can say that for 1 mole of aluminium oxide, we require 6 electrons. For 2 moles, I will be requiring 6 into 2. For 3 moles, I will be requiring 6 into 3. Okay, for 4 moles, I will be requiring 6 into 4. But how many moles are we having here? We are having 2 by 3 moles. So we will be writing 2 by 6 into 2 by 3. Now it makes sense. दो चीजें हो रही हैं, ध्यान दीजिएगा. Once again, I am telling you. First of all, we are going to look at the change in the oxidation state for aluminium. For 1 aluminium, right? 1 aluminium is going under change +3 to 0. In this molecule only, we are having how many aluminiums? 2 aluminiums. Okay. So for 2 aluminiums, there will be a change of 6 electrons. If I had 2 moles of aluminium oxide, so 12 electrons. If I had 3, then it will be having 18 electrons required. But right now, how many moles of Al2O3 we are having? 2 by 3. So that's why 6 into 2 by 3. Now it makes sense, yes or no? Please tell me, guys.
Yes, sir.
Yes sir. So we should take N as 4 electrons.
Yeah, N has 4 electrons, correct. Because the thing is now, they have given us the delta G of this reaction. जहां पे reaction में क्या है आपके पास 2 by 3 Al2O3 है. This reaction उन्होंने इसके लिए नहीं दिया है, प्लीज अंडरस्टैंड. Al2O3 गिविंग यू 2Al plus O2. इसको बैलेंस कर लीजिए जो भी हो रहा है. They have not given the delta G for this reaction. No, they have given the delta G for 2 by 3 with the stoichiometric coefficient. Those are also important. If you remember a bit of thermodynamics, then you will remember that enthalpy of formation, it had a particular definition. And if they said enthalpy of formation, for example, enthalpy of formation क्या होता है? For example, enthalpy of formation of ammonia. So you will have 1 mole of NH3 only. 1 mole of NH3 made by its constituent elements in their most stable state. So nitrogen in its most stable state will be N2. Hydrogen in its most stable state will be H2. ठीक है? Enthalpy of formation का जो equation होगा, it will be not like this. It's not the formula for enthalpy of formation. What you need to do, you need to have 1 mole of product. उसके लिए आपको ना 1 by 2 करना पड़ेगा. यहाँ पे जैसे 1 by 2 और 3 by 2. This is exactly the enthalpy of formation. अगर आपको दिया हो delta HFNH3 is equal to x joules, then they are giving the they are giving the enthalpy for this reaction 1/2 n, not for n2 plus 3h2. उसके लिए नहीं दे, ठीक है? ये देखता है, ये थोड़ा सा हम divert कर गए, but please send your answers on my WhatsApp.
Sir, shouldn't it be minus MFE, sir?
Yeah, it will be minus like that. It will be minus only. Try to get approximate answers. Yeah, your answer is fine, but decimal point के बारे में थोड़ा सा, can you please recap decimal point?
Yes, sir. Manu.
The numbers are correct. हाँ, हर्षा इतना कमा रहा है. Harsha, can you also please check the decimal points? Some, by the way, nice approximation, Harsha. It will be negative, by the way, here, and negative में आएगा answer, not in positive, because we'll be giving electricity for this reactor. By the way, see here, guys. Minus delta G is equal to 9640. 1, 2, 3, 4 zeros, you know, 960 kilo, हाँ, the 4 zeros, ठीक है. Divide by n. What is n? 4 into 96500. So 1010 1010. ठीक है. By the way, approximately I can say now 965 into 10. approximately क्या ख्याल है 965 into 10 will be equal to 9650 है ना, so which is approximately equal to 9600. It will be 9.8 9.9 उतने करीब आएगा, ठीक है. So what is 10 by 4? It is minus 2.5. 10 by 4 will be equal to 2.5 now. 2.5 into 4 you will get the value 10. Approximately you will get this value minus 2.5 volts. This is the E cell. So what is the potential difference required? Potential difference required is equal to 2.5 volts. ठीक है, यहाँ पे ध्यान दीजिएगा. Why I'm not writing the negative sign here? Because I have already written required. So when I say required, that means I am going to invest that much volts. ठीक है, so potential difference required will be equal to 2.5 volts. E cell will be minus 2.5 volts. That minus sign, that is telling us, that's giving us an idea that 2.5 volts of energy it is required. Does that make sense? Yes or no? Please tell me. All of you understood? Negative, positive?
Yes, sir.
Okay, very good. Yes, that is also correct. Please put the unit as volts.
Sir, so the reaction won't take place.
Sorry, what, Harshan? Can you repeat that?
Sir, so the reaction won't take place.
No. Reaction will take place, but we will be giving electricity. The reaction will not be giving us electricity. It will not be a galvanic cell, rather it will be the electrolytic cell. Okay. Electrolytic cell in which we give electricity for the reaction to occur. That is the next part that we are going to cover today. We will just introduce the electrolytic cell and the factors affecting that we are going to do next time. Or we will write a bit of factors, but we are going to take the electrolytic cell in the next class. Today we are going to take the introduction of electrolytic cell, the examples of electrolytic cells that we are going to take in the next class. We will be able to cover this in half an hour. It's fine. I hope you have written this, guys. Those who are writing. Anyone still writing? Please let me know. Anyone still writing? Please let me know. Anyone still writing? Writing. Right, writing. Electrolytic cell. Electrolytic cell. So here I will write the cell in which non-spontaneous redox reaction occurs, due to which electrical energy is converted to chemical energy. Basically, we have to do a chemical reaction for which electrical energy is required. For which energy is required, we are providing electrical energy in this case. Okay. Also write one more point. The process of decomposition of compounds, into ions by the passing of electric current by the passing of electric current in molten or aqueous state is called electrolysis. It's called electrolysis. Okay, these are just introductory points. These are not very important. The next point that I am going to write now, those are going to be very important. Okay, but those are also self-explanatory. What it is self-explanatory? See, if I'm going to add any electrolyte in any, if I'm going to add any electrolyte into water, or if I'm going to melt it, then I will get cation and anions. And if I put up a battery with 2 electrodes, what will happen with the cation? Cation will move towards the negative charge. Anion will move towards the positively charge. Okay, so that's what's going to happen. We are going to write those points. Okay, so please write with me.
Sir, can you go up?
So go up. Done here? Let me know once you're done.
Done, sir.
Okay, please write down. When electrolytes are dissolved in water, when electrolytes are dissolved in water, dissolved in water, or if they are in, or if they are in molten state, they split into ions. They split into ions. ठीक है? Then next point. On passing current, the ions are attracted towards oppositely charged electrodes. Meaning the cations, they will move towards a negatively charged electrode, and ions will move towards the positively charged electrode. Okay. Right, next point. Anions reach anode and get neutralized ठीक है, that is ध्यान दीजिएगा, ठीक है, थोड़ा यहाँ पे ध्यान दीजिएगा. Anions will be having what charge, positive or negative?
Negative.
Anions में क्या charge होता है? Negative.
Negative.
Very good. Negative charge. And when it will get neutralized, what will be the charge on that species? जब anion neutralize हो जाएगा, तो what will be the charge? Neutral में क्या charge होगा? 0.
Yes, sir.
I hope है ना 0. So negative से negative to 0. Negative to 0, this will be increase in oxidation state or decrease in oxidation state. बताइए जरा, जैसे example -3 to 0, यहाँ से -3 to 0 increase हो रहा है, decrease हो रहा है? -3 to 0, it is increase or decrease?
Increase.
Increase.
Increase in increase. So whenever the oxidation state increases, it will be what? Oxidized, na? Oxidation हो रहा है. And also because it is anode, oxidation will happen. So anions reach anode and get neutralized. What is the meaning of neutralized? That is oxidized. That is oxidized. Next you will write cations reach cathode and get neutralized. That is reduced. Next point you will write movement of cation and anion is called electrolytic conductance, and the change is known as primary change. Change is known as primary change. This Na positive will get converted to Na, that is the primary change. That is last point regarding the electrolytic cell. For electrolytic cell, EMF will be negative and delta G will be positive. Because negative sign of E cell is telling us that we are giving electricity. Delta G का मतलब क्या है? Delta G is positive, that means it requires energy. This process is going to require energy. Copy this down, raise your hand once you're done. Wait for Mariam and Siddika. Mariam, not the old Mariam. Regular class Mariam, but trial class, waiting for trial class. Mariam, I think it will be better that we can, if we have one more trial class where you have access to your mic, okay, that will help me understand how much you are understanding. Waiting for Siddika also. Siddika, done. Just waiting for Mariam, I think. How much should I wait? Itna I think कर लिया होगा ना. If she has not written, then she will let me know. Okay. Now, in this electrolytic cell, there are two things we are going to talk about. First thing that we are going to talk about is the qualitative analysis. Qualitative analysis means if I have, let us suppose, a solution of NaCl, or if I have a copper sulfate, or if I have copper chloride, or if I have AgCl, or if I have concentrated H2SO4. So when I am having these solutions and I pass electricity in it, what products I will be getting? Because there will be some reaction happening and we are going to predict those reactions. We are going to predict those reactions. So that is qualitative analysis of electrolysis, or the topic can also be written as products of electrolysis. That is the first topic. Another topic that we are going to do is the quantitative analysis. Quantitative analysis, or the another topic name that you can write is Faraday's law. In quantitative analysis, how much of the product is? Basically, there are two portions. What are the products? How much are the products? First, we will look at what are the products. Then we will look at how much is the product. Okay. So, because we have done a bit of things today, hopefully in the next class we'll be able to do both of them. है ना? तो यहाँ पे एक topic तो जरूर लिख लीजिए. Qualitative analysis of electrolytes. Because we are going to start this topic, but we are not going to take any examples of the cells. ठीक है? Because after a week you all will forget everything. Okay, so please write qualitative analysis of electrolysis. Okay. Or the name of this particular topic would be products of electrolysis. Products of electrolysis. होता ही है ना? Some students they do self study, and they will be doing self study from different books. Some books they will write qualitative analysis. Some books will write products of electrolysis. किसी एक बच्चे ने देखे ना products of electrolysis तो सर आपने नहीं कराया. They will not even care to look and say the topic. Topic में है क्या? ठीक है. So please write the criteria. The criteria for the formation of product during electrolysis depends on the following. Depends on the form. Okay, please write these things with me. First one is nature of electrolyte. Nature of electrode. Nature of electrode. क्या मतलब इसका? If I am having NaCl, then there will be some different product. If I am having CaCl2, calcium chloride, then the products will be different. So depending on the electrolyte. Another case is mode of electrolyte. Mode of electrode. क्या होता है इसमें? It could be the electrolyte could be in aqueous state or molten state. Sir, उससे क्या फर्क पड़ने वाला? In aqueous state, you will have one more chemical species, that is water. So water may interfere somewhat. है ना? How it may interfere, that we are going to look in detail when we are going to look at the examples of the different electrolytic cells. The third one is nature of electrode. Nature of electrode. So what type of electrodes are we having? We are having inert electrode. ये तो platinum वाला आप लोग ने देखा था. You have seen that in standard hydrogen electrode also, right? Inert electrode, or it could be active electrode. Now, what is active electrode? Active electrode are those which can take part in the reaction. So that can also cause some type of interference. Fourth is concentration. Concentration of solution. Concentration of solution. ठीक है, कंसंट्रेशन हाई या लो, कंसंट्रेटेड और डाइल्यूट, इन्हीं दोनों में हम लोग खेलेंगे. ठीक है, प्लीज राइट दिस डाउन, रेज योर हैंड वंस यू आर डन.